Welcome to this video. Today we are talking about Science for Standard 7, Force and Motion. Science for Standard 7. Now when you come to school today, from home, you travel a few kilometers. Inside the school, after you enter the compound to reach your classroom, you travel a few meters. Now it is not necessary every day you take the same route. Your school bus or your parents may not take the same school route to take you to the school. Likewise, inside the school also, from the gate to the classroom, you will not take the same route. So it is possible that your school is 10 kilometers away from your home, but some days your car or bus has to travel 11 kilometers or some days 9 kilometers depending on the route they take. So what is this? So for example, if you are traveling like this on a particular day, you are traveling 10 kilometers. If you travel along the blue line, you are traveling 7 kilometers. But actually from your home to school is only 5 kilometers far from each other. So this is called the distance traveled, while this is the displacement. A to B is the displacement when it is a shortest straight line distance. But actually the path that you take will make you move a longer distance, and that is called the distance travel. So this is the difference between distance and displacement. The length of the path taken by any object to reach one place to another is the distance, right? So if you take this route 1, you will have to travel 10 kilometer. If you take route 2, you will have to travel 7 kilometer, and this distance is always positive. This distance is always positive because from traveling 0 kilometers, you have to add a few kilometers by traveling going on and on and on till you reach point B. This is distance. But displacement is the shortest distance from the initial point to the final point of the object. If the object is starting from A, if you are starting from home and if you are reaching school, or if you are starting from school and reaching home in the evening, the shortest distance between these 2 points is the displacement. Now this displacement can be positive or negative. Why positive or negative? If you travel like this, it is positive. If you travel reverse, it is negative. So the distance can be positive or negative? No. Distance can always be only positive. But displacement can be positive or negative. Displacement can be positive or negative. The magnitude of displacement can be positive or negative. Magnitude means what? This 5. Kilometer is a unit, 5 is the magnitude. So this can be plus 5, this can be minus 5. But this 10 is always plus 10, this 7 is always plus 7. How long did you travel? How many kilometers did you travel? If somebody asks, you cannot say I traveled minus 5 kilometer. But if you ask what is the displacement between A and B, then you can say it is minus 5 kilometer. What is the SI unit? SI unit for is meter. SI unit is meter. So when an object travels from one place to another, it will reach faster if it travels along the path of displacement. This is a straight line. If it travels on a straight line, it will reach faster. But can you travel in a straight line? Cannot. Why? Because there are in between roads, buildings, trees, so many things, right? So you will have to take a detour. You have to turn here, turn left, take 3 right turns, take 4 left turns, take 1 U-turn, wait at the signal. So because of all that, you will not be traveling on a straight line. So you will normally not be traveling on a straight line. You will normally not be traveling on the displacement path. Now this is same for the ship, this is same for the air, this is same for everything. It is not only for road or not only on drawing a paper, right? Because traveling on a straight line path, the shortest distance path may not be possible. That is why distance and displacements are different. Now when will the distance and displacement be equal? It will be equal if the distance travel is along the line of the displacement on the shortest path. When will the distance traveled by a person be 20 km and displacement 0? Now when it will be 20 km and displacement 0? For example, from A, if he is traveling this much distance, then he takes a right turn, then again he takes a right turn, then again he takes a right turn. Then what will happen? 4 times he is traveling equal distance and 3 times he is taking right turn. Here one right turn, here one right turn, here one right turn. So what is it meaning? 5, 5, 5, 5. What is it? 5, 10, 15, 20. So he is traveling 20 kilometer, of a 5 kilometer each into side square and is coming back to the starting point. So the displacement is 0. But he had actually traveled 20 kilometer. 5, 5, 5, 5 like this. So that is how the distance and displacement are related to each other. What is nautical or not? When ship or aeroplane moves, they say the speed or the distance is measured in nautical miles. It is measured in nautical mile. How much is a nautical mile? 1.8 kilometer is a nautical mile. 1.852 kilometer is a nautical mile. This is the measurement. And what is not? Not is the speed. Speed means what? 1 nautical mile per hour. That is 1.8 kilometer per hour. This is the speed at which the ship or the aircraft moves. Aircraft speed, if you ask how much it is, they will say X knots, Y knots. If you ask the distance, they will say they traveled so many nautical miles. 1.852 nautical mile. Kilometer is 1 nautical mile, 1.852. So nautical mile is a unit for measuring the distance in the field of aviation or sea transport, maritime transport. Unit for measuring the speed is knot. Now let us look what is speed. Now we know what is the distance, what is displacement and what is a knot. What is speed? Now when you are running a race, suppose you have a circular or oval shaped ground and if you are running from here to here when you run, the shortest distance is, so for example 50 meter, but when you run along the path notified, you will run a 200 kilometer race or a 100 kilometer race or whatever, right? So when you are moving from here to here, it is only 50-meter displacement, but you are actually running 200 meter to reach this place. Now how do we measure speed? Speed is the distance by time, distance traveled by time or rate of change of distance. Speed is distance by time. Distance by time means what? Rate of change of distance per unit of time. That means what? Meter per second. How many meter in 1 second did you go? If you go this many 200 meters in 10 seconds, then it means what? 100 meter in 1 second. So it is 100 meter per second speed. So this speed can be uniform, cannot be uniform. What is uniform speed? Body in motion, this is a person who is running, covers equal distance in equal interval from first second, second, third second, fourth second, all the 10 seconds, he is running at the same speed. That is uniform speed. Body in motion covers equal distance in equal time. Mostly this is not possible. It will be non-uniform speed. What it is it? Body covers unequal distances in equal intervals of time. Body covers unequal distance in equal intervals time. You will know when you are in a car or a bus or an aeroplane, when you start, it will be a little slow for the first few seconds. And then you will pick up speed. And then you will gain speed for some time. And then when you reach a stable speed, then the increase in speed will not be there. You will keep moving at a stable speed. Likewise, when you are coming to a stop, then the speed will come down very fast and then very slowly it will come down and you will stop. This is how it is. So that is why a body will cover unequal distances in equal intervals of time usually. So if there is an uniform speed and a non-uniform speed, what is the average speed? Average speed is total distance travelled by total time taken. All of this 200 meter he took 10 seconds, then or 20 seconds. Then how much meter per second is the average speed? That is how we calculate saying distance by time, rate of change of distance. What are the units of measurement? Kilometer per hour. What is kilometer? 100 meter. What is hour? 3600 seconds. So it will become 5 by 18 meter per second. It is kilometer per hour or 5 by 18 meter per second. This is how we measure the speed. Coming to velocity. What is velocity? Velocity is displacement by time. This is displacement 50 meter. And again the same 10 seconds. If you took 10 seconds to run on this circular path 200 meter, it is 200 by 10 is the distance covered by time. But displacement by time is 50 by 10. This is the rate of change of displacement, not rate of change of distance. This is rate of change of distance. Speed is rate of change of distance. This is rate of change of displacement. Velocity is rate of change of displacement. How do we measure? Again, distance by time is the speed, but velocity is displacement by time. What is displacement? 50. So V equals to d by t. V is velocity, d is displacement, t is time. V equals to d by t. So rearranging the formula, time equals to distance by velocity, displacement by velocity. Time is displacement velocity. Displacement equals to velocity into time. Displacement equals to velocity in time. What is velocity? Displacement per time. Again, we have uniform and non-uniform velocity. Uniform velocity covers equal displacement in the same direction. Equal displacement in the same direction in equal intervals of time. Equal in the equal covers equal displacement in the same direction in equal intervals of time. Non-uniform velocity is what? Either the speed or the direction changes. It is not in same direction. It is not in the same direction, or it is not equal displacement. Unequal displacement. Unequal displacement means unequal speed. So either the speed changes or the direction changes in non-uniform velocity. In uniform velocity, equal displacement in same time. Right? Now, what is average velocity? If there is something called uniform and there is something called non-uniform, then we normally depend upon average velocity, total displacement by total time taken. This is average speed is total distance by total time taken to cover the total distance. Total displacement by total time taken is the average velocity. So, this is speed and velocity. So if this is speed and this is velocity, then what is acceleration? Acceleration is rate of change of velocity. Rate of change of velocity. So speed, rate of change of distance. Velocity, rate of change of displacement. Acceleration, rate of change of velocity. So when do we measure this rate of change of velocity? If a body changes its speed or direction, then it is said to be accelerated. Now here we have seen, if it is in the same direction, equal displacement, equal intervals of time, uniform velocity. If either speed or direction change, then it is non-uniform velocity. So if the body changes the speed or direction, then it is accelerated. That means if it is non-uniform velocity, then there is acceleration. If the body changes its speed or direction, then there is acceleration. That is change of velocity by time. Change of velocity by time. How? Final velocity minus initial velocity by t. V is the final velocity, u is initial velocity, v minus u by t. How it is measured? Meter per second square. Meter per second square. So acceleration equals to final velocity minus initial velocity by time, meter per second square. Cheetah. What is the speed of cheetah? Is the fastest animal we know. What is the speed? 0 to 20 meter. 0 to 20. It goes how? In 2 seconds. How much is 2 seconds? Is 2 seconds. Right? So this acceleration, that is rate of change of velocity, can be positive or negative. What do you mean by positive? When the rate of change of velocity is keeping on increasing, that is when you are increasing your speed. What is speed? Speed is change, rate of change of distance. Velocity is rate of change of displacement. Acceleration is rate of change of velocity. When it is going on increasing, then it is positive acceleration. When the car is starting and going out, it is acceleration. When the car or a bus or an aeroplane is coming to a halt, it is deceleration. Deceleration is negative acceleration, that is retardation. What is that? Retardation, deceleration, negative acceleration is velocity of an object decreasing with respect to time. Decreasing with respect to time when you are going to come to a halt. So if you have positive and negative, or if you have non-uniform, non-uniform, then what do? We go for average, right? So here also you have a uniform acceleration. What is that? The change. The change can be increase or decrease. Why? It can be positive or negative. It can be acceleration or deceleration. It can be retardation. The increase or decrease in the velocity for every unit of time is the same. That is uniform acceleration. First minute, the rate of change of velocity is acceleration. The change that is increase or decrease in velocity is 1 unit for the first minute. Second minute also 1 unit. Third minute also 1 minute. That means uniform acceleration. Non-uniform acceleration. What is that? The change in the velocity for every unit is not same. Whether it increase or decrease is not same. That means what? First minute it is at x. Second minute it is y. Third minute it is z. So like that, if it keeps on changing, the change in that is increase or decrease. The change is not same for every unit of time. Change of what? Change of velocity. Why? Change of the velocity or the rate of change of velocity is acceleration. If that is the case, then how do we measure the rate of change of the speed or velocity or acceleration? Now let us record time and distance on a graph. This is a distance 125 km for example, or this is a 5 hours for example. This is time per second, meter per second, or kilometer per hour, whatever we can change the legend. Suppose this is the graph has an increasing gradient speed. Increasing gradient. Increasing gradient means what? The curvature is increasing. This means what? Speed is increasing. When speed is increasing, the graph has increasing gradient. Now, if the speed is decreasing, then the graph will have a decreasing gradient. This is what? This is coming down. This is coming down. Decreasing gradient. If it has a decreasing gradient, then means speed decreases. If the graph has increasing gradient, speed increases. If the graph has decreasing gradient, speed decreases. This is the time and distance graph relationship. So, if the graph has zero gradient, that means what? If it has zero gradient, then the speed is constant. Speed is neither increasing nor decreasing. Speed is constant. You are going at 100 km per hour speed constantly. So, this is 20 meter distance on the first second. Second thing, again, the same at the constant speed you are going. If the speed is constant, the gradient is zero. Now, this gradient, graph has zero constant gradient. This is zero gradient, zero constant gradient. That means what? Distance increases 10 meter for every second. If you look at this, for the first second distance, for the second it is 20, third second 30, distance increases 10 meter for every second. That means what? The speed is increasing constantly. For every second it is 10. Second it is only 10 because becoming 20. It is not becoming 30. Third second it is increasing only 10. The constant increase. If there is a constant increase, the graph will have a constant gradient. Zero gradient, decreasing gradient, increasing gradient, and this is constant gradient. This is the relationship between time and distance. Now let us look at the relationship between speed and time. Now increasing acceleration. Here we saw increasing speed, decreasing speed, constant speed, and distance increases 10 meter for every second, constant gradient, right? Here increasing acceleration. Speed is increasing with the time. If you look at this is small, this is bigger, that means what? It is increasing. The graph has positive and increasing gradient. Graph has positive and increasing gradient when it is increasing acceleration. Now, increase in speed is decreasing. Increase in speed is decreasing. Increase in speed is increasing. Positive and increasing. Increase in speed is decreasing. That means what? It is positive and decreasing gradient. The graph has a decreasing gradient. Here the graph has an increasing gradient. Here graph has a decreasing gradient. But both are positive. Why both are positive? It is increasing acceleration. Why? Speed is increasing. Here also it is. But the increase in speed is decreasing. Speed is actually increasing, but the increase in speed per second is decreasing. Speed is increasing. Here speed is increasing, but increase per second is decreasing. Increase per second is increasing. Increase in speed is increasing. Increase in speed is decreasing. That's the difference between these two graphs. Now here what do we have? Here we have graph has a positive and constant gradient. That means what? Speed of the car increases by 10 meter per second. Speed of the car increases by 10 meter per second. Constant increase. Here this is uniform deceleration. This is uniform acceleration. Constant acceleration. This is constant deceleration. Uniform deceleration. That means what? Speed decreases. The graph has negative constant variant and the decrease is same. For every second it is 10. Speed of the car decreases by 10 meter per second. This increases 10 meter per second, decreases 10 meter per second. Both are constant. What? Acceleration. But this is constant positive acceleration. This is constant negative acceleration or deceleration. This is a speed and time graph. So these four graphs and these four graphs, if you know, that means you have a fair idea about the distance and time or speed and time. Now let's compare. If you are going by car and the car accelerates uniformly from rest, the car is stopped here and then you have switched it on and they are accelerating, it will go up. And then at constant speed it will keep on going. And then it will start decelerate. It is the speed will come down uniformly and it will come to a stop. This is the distance time graph. But if we are looking not at the distance time graph, if you are looking at the acceleration graph or the speed time graph, then the y-axis is the speed and this is the distance. speed will increase fast because speed increases uniformly over time. Here distance only increases, here speed increases over time. Then the speed does not increase, speed is constant. So it goes at the same speed and comes down. This is how you will measure the speed. Speed goes up, constant speed, speed comes down. Speed is constant. Speed is constant. Speed increases, speed decreases. This is what we said. Increasing gradient, decreasing gradient, constant speed but acceleration, constant speed but deceleration. Constant speed acceleration, constant speed deceleration. But here it is like this. Why it is like this? This is increasing gradient, speed increases, decreasing gradient, speed decreases, speed is constant and increase is constant. So here what happens? Distance moved increases, more distance A to B, the distance moved is covered at an increasing rate. Distance moved increases at increasing rate. Here distance moved increases uniformly over time. Gradient is the positive constant. This is how we compare the distance time graph and speed time graph, right? Now what is gravity? The point through which the entire weight of the object appears to act is called gravity. When you are studying force, we are studying gravity. Why? Force, the gravity is the force by or due to or from the center of the earth or by any celestial body. The force with which any celestial body attracts any other body towards its center is gravity. The force with which any celestial body attracts any other body towards its center is called gravity. So apple fell down, Newton found out because of Earth's gravity, apple fell from the tree to the earth. When you are standing on the moon's gravity will be acting on you more than that of the Earth's gravity. So this is the gravity. Every celestial body has a gravity, a force with which it attracts other bodies towards itself. The point through which the entire weight of the object appears to act is the center of gravity. That means what? If it is a square, this will be center of gravity. If it is triangle, you draw three lines from each corner and the point where it intersects is called the center or the point through which the entire weight of this two-dimensional object appears to act. This is called center of gravity. This is the geometric center of the object. If it is a circle, if it is a ring, if it is a square, if it is a triangle, it is a geometric center of the object, is a center of gravity. What is so special about it? Because the force with which the body, this object falls on earth depends on where the center of gravity is. If it is a regular shaped object, then you can easily find out because it is a geometric center. If it is irregular shaped, mostly it will be at the center of object only. Now, ruler is in equilibrium when supported at its center of gravity. So, a scale, when though it is long, it is a possibility it will fall down. It is in equilibrium when it is supported. When it is in equilibrium, it will be supported. When it is in equilibrium, it will not fall. When it is in equilibrium, it will stand balanced. Why it will happen or when it will happen? It will happen when you are holding it from the center of gravity. If you are holding it from this blue dot, irrespective of whether it is a curve or rectangle, triangle or a ruler, then when you are holding it from the blue dot, that is the center of gravity, it will be in equilibrium, it will be in balance, it will be supported because that point is the center of gravity. If it is not in equilibrium, if it is not supported, if it is not balanced, that means that is not the center of gravity. Now why we need to know center of gravity? Because only if you know where is the center of gravity, we will know whether there is a stability or not. Now, what is stability? Stability is ability of a body to maintain the original position, ability of the body to stay the way it was. Now, suppose take a conical thing like this. Now, this center of gravity, when you tilt from this black line to this blue line or the other way around, when you tilt, the weight moves. This circle is the base. Right, the center of gravity raises when you tilt. The center of gravity raises from the, because of this circle, we know if it is circle it has to be here, even if though it is conical, but it is raised to another place. The center of gravity moves from this point to the red arrow point because of the pivot. But then what happens? Even though it moves, as long as the center of gravity, this vertical line, the moment of weight is the vertical line. As long as this vertical line, dotted line, and this arrow lies within this base, as long as it lies within this base, there is nothing to worry. That means what? It will have stability. That means what? The frustum can be tilted. The frustum can be tilted any big angle without a toppling. When and without toppling means what? It will return to original position when, as long as the vertical line through the center of gravity falls within the base. So as long as the center of gravity or the vertical line through the center of gravity falls within the base, the fulcrum, though tilted to a big angle, will not topple, but the object will return to the original position. That is called stable. An object is called stable, or object is said to have stability if the fulcrum can be tilted to such an extent to any angle so that the line through the center of gravity always remains within the base. The vertical line through the center of gravity falls within the base. In such a case, even if the fulcrum is tilted, whatever be the angle, it will not be toppled, but it will try to regain its original position. This is stable. What is unstable? The frustum is tilted, and even with the slightest tilting, the vertical line through the center of gravity falls outside the base, and because of that, it does not return to the position but topples. The frustum, when tilted, if the vertical line through the center of gravity falls outside the base, even for a small angle, then it will not return to original position but will be toppled. Then it is unstable. That means what? The center of gravity has been displaced. Here is what the moment of weight says: center of gravity raises but not displaced. This is stability. Now there is an important thing. You would have seen a doll like this. It is called Tanjore doll, right? It is very famous that whatever you tilt, it will bend, turn, everything it will do, but it will not fall down. Why it is happening? Because it is heavy at the bottom, because the base is large, because the center of gravity is very low. So here the center of gravity, though it is low, the base is small, right? Here the base is large. Now it causes the frustum to topple, right? The frustum will roll but will not topple. If you turn like this is the line of the center of gravity. Whatever you do, the center of gravity will lie within this red thing, which is the base, because this is a spherical. Here is what the base is. As long as the vertical line through the center of gravity lies within the base, this will not topple. This will turn, twist, tumble, but will not topple. The center of gravity remains at the same height. It remains at the same height because this, whatever you tilt, it will remain there, and the body will stay in any position to which it has been displaced. Means what? Now it is displaced. This yellow has come from the straight line to here. This will come to the position. It will come back to the position. So if you lower the center of gravity, if you increase the area of the base, if you make the bottom heavy, then you will get more stability. That means what? You will help the object to retain its neutral equilibrium quicker. Where do we use this concept then? Racing cars are built low. Why? Because the lower center of gravity will remain low, so it will not topple. And then it is built broad. Why? Howsoever you topple, it will not topple down, it will only tremble here and there, because the center of gravity, if the base is broad, will remain within the base. This example is also used in table lamp or fan. When you have a table lamp, when you put it on the table, the top of the table where the bulb and the fulcrum is there, that should not be heavy and fall down. For that, the bottom is made heavy and flat. Likewise, the table fan is also done in this fashion, right? Okay. Now we have studied speed, we have studied the distance and displacement. Now what actually is speed? Speed is reaching fast or going fast. And who is fast? Tortoise is only 1.1 meter per second. 0.1 meter means what? 10 centimeters, right? Person is walking 1 meter per second. In 1 second, you can maximum walk 1.4 meter. Tortoise is zero point 0.1, person is 1.4. Raindrops are falling 10 meter per second. That means what? Raindrops are faster than man. Cat can run 14 meter per second. Cat is faster than the rain. Cycling is 25 kilometer per hour. 25 kilometer per hour. Cheetah is 31 meter per second. Bowling, when you bowl in a cricket, it is 100 miles per hour. Badminton or squash, when you hit a ball, it is 90 meter per second, 100 meter per second, faster than the cheetah. You are hitting the ball. Passenger jet is 180 meter per second. Passenger jet is 180 meter per second. So we were discussing a little bit about the force and motion. Thanks for watching this video. Please keep coming back for more videos on science and social science for Samachir Samagraha.